First off, tonight we have Chuck Doolittle from Gray Bar, who's our host here. By the way, thank you as always for hosting us. Appreciate it. And he's going to talk to us tonight about VPN. So I'll turn it over to Chuck.
And we are recording.
Well, 2 minutes. But I got this up if you want to talk about something else.
Okay. 2 minutes, we can talk about time.
Does anybody really know what time it is?
Let's see.
You have 2 minutes worth of announcements we can start with.
Yeah, I can start with something, I'm sure. Actually, it's a good point. This week is that weird week where the third Thursday falls the day after the second Wednesday. Which means that the St. Louis Lug meeting is tomorrow night, whereas normally it's next week. So tomorrow night there'll be the St. Louis Lug meeting. That's up at Umsel's IT Enterprises, their business incubator, and it's basically the part 2 of what Chuck's doing tonight. So if there's questions that you have after you think about what Chuck talks about tonight, and tomorrow night he's going to specialize more on OpenVPN. So we'll get into some other specifics tomorrow night. So. And then next week there's the SNUG meeting, the SUSA Novell meeting on Wednesday at noon. There's also a free lunch involved in that, so by all means, anybody wants to come. And we'll probably be talking, I don't know the exact topic, but it'll be something about SUSA, I'm sure. And next Wednesday night is the Prolongers meeting. Any topic yet?
Well, last month everyone got S&P to all over the books. So we're going to try and work on this podcast.
Oh, cool.
So I think exactly interested in figuring out how to do that. We will, and there's one guy I ran across at a burlesque show back last Saturday who actually understands how to do it. So he's going to try and help us figure out how to set everything properly so we can get these recording.
Okay.
Choosing the equipment is one of the first steps, I think.
Yeah, but actually, the podcast is kind of useful for a lot of things. So there's St. Louis, there's so many groups. No one's going to go to all of them because you never get home. Mm-hmm. And I think more of the groups started recording themselves. We had a decent format for it. It helps people who are in darker corners of the planet where they can't get somebody to speak every time. They can at least see something. And for the groups here that you miss, you can at least fast forward and talk. More of the local groups got decent at it. The problem is it takes a couple of shots before you actually get the rhythm right. Generate a decent podcast, so you have to sort of try it out a few times. So we're giving people a chance to try it out. Friendly audience. No cabbages, I promise.
Tomatoes, maybe. Tomatoes?
Go.
Beer?
Or no plastic
If you want to
chicken?
drink some, feel free. And we have free beer.
We don't throw it.
Oh. I bring better beer than most places.
He does.
We
He
do
does.
have decent.
He brings some good craft beers. There's some good stuff.
Well, it's a nice thing. The Schnucks stuff on the do. If you go in, they got this huge beer. I mean, it's an entire island of beer. And at the left end of it, they've got all the 750s and really nice stuff. So you can walk in and get 4 bottles, big bottles of nice beer. So you can bring a few of those. Virtual private networks. You guys see it.
Alrighty. Okay, we're gonna go into the talk and we'll pick up on stuff later.
All right. Well, thanks, guys. Today, I'm going to start talking about virtual private networks, and we'll see how far we get. I'm Chuck. I think everybody recognizes me at least.
Hi, Chuck.
Hi.
And I'm a Linux. Hi, my name's Chuck, and I'm a Linux user.
I'm a recovering Microsoft victim.
Besides what I do 9 to 12 hours a day, I am also the CIO of a little operation known as Heritage Information Radio, an online and local AM station located all the way out in Norwich, Connecticut.
They play some nice classical music.
Well, thank you. We try. The program director appreciates that.
You ever broadcast?
Hold on, let me pat him on the back.
If you want to broadcast some Pearl Talks, you've got.
The little old ladies that listen probably wouldn't care much. One of the things it's Heritage Information Radio. We have a national, what's called a National Heritage Corridor out there in the eastern end of Connecticut and the southeastern area in Massachusetts. That they say at night it's the last green strip of land, or the last green or dark strip of land you can see in New England. It's so sparsely populated. We do some work with the last green valley. It's called. Go to tlgv.org as well. There's an email address for you, which should work for quite a while, hopefully. So here we go. Okay, so I know a lot of people have heard about VPNs, but what exactly is it? Well, it's virtual. Hey, meaning there's no hardware. It's all done as software constructs. On Linux, if you have root, you can do it. It's private, can't be intercepted between the endpoints. So anybody that sniffs anything out on the open internet, even if you're passing unencrypted traffic between the sites, all they're going to see is gobbledygook. Of course, cannot always has a star after it. Now, if somebody's really interested in you enough that they can intercept it, you probably have bigger problems to worry about, including which country you want to seek asylum from. And network. It's a network. It's just a regular either point-to-point connection or appears as an Ethernet section. So normal TCP/IP addressing and routing all work. You can do pretty much anything you can do over an Ethernet adapter, you can do over this. So why do people use VPNs? Well, number one is privacy, of course. That's a nebulous concept, but as it applies here, it goes back to the thing where, if you're passing unencrypted traffic, it can't really be sniffed between locations. One of the things that came up on the discuss list this afternoon was using it to appear as if you're in different places in the world. That's geolocation. Well, if we get it that far, I've got a demonstration of that later on in the slide deck. One of the more useful ways to do it is connecting multiple devices, either at one end or both ends, or not. There's really an infinite number of ways you can configure these things. We'll get into some examples later. I can have my laptop, I can connect to a VPN and connect to every server or every machine at a remote site. Or I can set it up so I can just talk to one machine at the other end, or I can have a bunch of machines here that talk to one machine at the other end. The sky's the limit. And if it's a recurring or permanent connection, if you support a remote site like I do, my buddy in Connecticut, the connection's always there. No matter where I get to from my phone, my laptop, whatever, I don't have to worry about setting up the connection. It's just there. It's just like it's another piece of Ethernet plugged in. As long as I can get logged into one of my servers, I can get anywhere. I can get to my house, I can get to his house. He's completely blind, as it turns out, so one of the things that this is really useful for is using remote desktop on his computer so I can see what he's doing or fix things for him. And there are some, I'll come back to the geolocation, but there are some reasons not to use a VPN, or maybe not to use a VPN. Some things you should really think about. Generally speaking, one-time connections are going to be easier to set up another way. If you only need access to a single IP or a single port at the other end, there's usually better ways. If you're unable to change firewall settings, if you're trying to break out from somewhere essentially, probably other ways. Generally speaking, SSH is allowed out of most places. Look at SSH tunnel. That's probably another talk. But generally, you can specify everything on the command line, one command, and it's usually quicker to set up, especially if you already have SSH keys and all that. VPN types, well, again, there's many, many kinds, especially when you get into the commercial services. Some of them purport to be anonymous. Some of them allow you to pick your own exit point. Now, if you're just doing this for yourself and you want to do some geolocation or something like that, they usually have a quicker setup than you can do. If you're doing more detailed thing, want more control, roll your own. It doesn't take that long, as we'll see later. Although it does take a little longer than just downloading a binary and running it. And consider the cost. No solution, unless you're moving many, many terabytes a day, should cost you more than $20 a month. You can buy VPS servers from DigitalOcean for $5 a month. That will be more than enough to handle your VPN traffic. If you want 2 of them for some redundancy, $10 a month and you're done. If you spend more than $20 a month, I'd love to hear your use case. I really would, unless you're running a real business. So back to the geolocation. Here's an example. If you want to appear to originate from a different location, whether that be New York City or San Francisco or London, basically you tunnel your way through the internet, and when you get to the server in whatever city it is, you appear on the net. When you appear on the internet, anybody else on the internet will think that you came from that location. Much to Lee's chagrin the other day, when Google decided to tell you that.
Oh, wait, I got one a couple weeks ago.
Yeah.
I was in Louisville, and that was one day I had to put me in Louisville.
Yeah.
But in another case, I was at a hotel in like Mount Vernon, and then geolocation had me in Dallas or something. Obviously, they were backhauling traffic out to the corporate network or something.
Exactly, and that's and it actually here at Gray Bar, anybody at one of our 250 field locations will appear to come from either Kansas City or St. Louis. Doesn't matter where you are. Typically, we run through here, but that's another story.
So you don't split out your public traffic?
We've talked about it. It's more of it's too much of a management nightmare. It's easier to backhaul everything and worry about it here than trying to filter it and go through proxies and all that.
Point of security too.
Yeah, that's exactly it. But if you're going to do something like this, consider the latency. May or may not care. If you're worried about appearing somewhere else, you probably don't care about the latency. But if you're going to send your traffic from here to London to go back to a server in California, the speed of light does come into play.
Well, the other point to make here is you're still exiting a fixed point. So whatever IP you got on your VPN is still traceable to you somehow.
Yes.
So this doesn't give you privacy, it just gives you separate geolocation.
Yes. Yeah. I prefer to, I'm trying to avoid there's lots of ways, if you stop long enough to think about it, that you could do naughty things. I will try not to enumerate them here.
No, if you believe in privacy, Tor may not have performance, but I guarantee you can't be tracked unless you got somebody out there with NSA quality tools.
Your OPSEC sucks, which is 99% of how people get caught.
Yeah.
They go to the same internet cafe 2 miles from their house every day to access Tor. Don't do that. Somebody will figure out that the camera outside the shop sees you walking in every day, 5 minutes before the guy logs in from a Tor exit point. Don't do that. And if you do, I have no sympathy for you.
And you call that OPSEC?
Operational security. We've been through here. Okay, so I need to rearrange those slides a bit. So generic VPN planning. We'll talk later about the OpenVPN stuff. But before we get through this list, this is a list of all the things that are coming up on the next set of slides. Are there any questions yet? Okay, Stan's not here. So some things to consider. Are you doing only site-to-site VPNs? Are you a business supporting a customer? Are you going to do user access, where you have people connecting from laptops and tablets or whatever anywhere in the world? You don't really know where they're coming from. A little of both, maybe. Ports and firewalls. I'll get into some specific examples later, but that's something to consider, and you should probably know where you're trying to get out of or get through. Passwords or certificates. We'll get into a little discussion about that later. Subnets. This requires probably the majority of the planning involved. Routing, service IPs, and network address translation. So, how many sites or users are you going to support? If you've got a couple of sites, we'll get down to where we choose between tunnels or taps later. That comes into play. How often will the users that you have change? If it's just me and my buddy, then you're probably not worried about having to hand out keys every other day, or twice a day, or 3 times a day. If you're a big enterprise, maybe you have some sort of password management system involved, and you wouldn't have to worry about it either. What type of devices will the users be using? Are they coming from PCs or desktops or laptops, or are they coming from their phones? I have a VPN client on my phone. I can browse my internal web servers from my phone, just like I'd be sitting on my network at home. Or tablets. Nowadays, pretty much all of the VPN software includes clients for pretty much any OS that you could run on, and pretty much any hardware. There's a client for all the phones, Android, Apple, Windows, Linux, you name it. Even AIX has an OpenVPN client. Ports and firewalls. Here, some trial and error may be needed. And some of that may be involved in how much you're allowed to adjust firewalls. Some of that may drive the need for a TCP or UDP. Generally, you're going to want to use UDP, especially on lossy networks. Anybody familiar with tunneling TCP inside TCP is familiar with the fallback routines, fighting each other. And if you start losing packets, it gets ugly much quicker if you're using TCP for your tunneling than if you're using UDP. Comcast, which will never be mentioned, throttles most standard VPN ports to less than dial-up speed. And I mean like 10K bits. Fortunately, they're pretty stupid about the way they do it. And the easy answer is use an alternate port. I have my buddy in Connecticut, I've got another guy in Springfield, Illinois that are on my VPN network, and they both use 92.01 and get full line speed.
What's the standard ports on VPN?
Depends what VPN program.
Okay.
OpenVPN is 1194. IPsec or L2TP is 500 or 4500. Those are the ones that come off the top of my head. But yes, we'll get into the ports later when we go into the OpenVPN stuff specifically. But this kind of applies to any of them. And the only reason I really found this was once we set it up, it was like, gee, it's really slow accessing my buddy's via remote desktop. I wonder why it's so slow. Well, let me ping it and see it. Yeah, well, long story short, it was pretty obvious. It works, it's just really painful.
So when you have a VPN, you're only connected to one port? Or is the whole connection on all the ports encrypted or whatever?
Your tunnel endpoint is one port.
Okay.
So you have, once it gets to that endpoint, it fans out to a regular network connection.
And you can figure that with your routing configuration.
Yes, yeah, and we'll get to that here before long, hopefully. Especially if there's not many questions.
Except the TCP versus UDP. So with TCP inside a TCP, you wind up with retransmits at what level? Internal.
at both levels. That's the
Both.
problem. That's the problem. They're essentially random, but every time it fails, it takes longer. And then because it failed, the next level will fail as well. If the external packet failed, then the internal packet will also time out. The internal packet then, because it was sent a tiny bit sooner than the external packet was packaging and sent off, failed first, which will then send another packet out. But because the external stream has not yet realized that the timer has expired, you will now queue up another packet. Lather, rinse, and repeat, and you basically, the fall off timer basically doubles instead of doubling every time, it's going up by a factor of 4 every time. And yeah, almost, if you can make it work, you can almost certainly find a way to make it work with UDP. And if you can, use UDP, because the TCP layer, the internal layer, handles the fallback for you. So you don't care, the external layer doesn't care if a packet just fell on the ground. So passwords and/or certificates. If you're site to site, you should use certificates. That's a pretty no-brainer thing. Now, you can discuss how often you want to reissue the certificates. By default, the EASY-RSA that comes with most people use for small instances, by default is a 10-year certificate. It's probably a little long if you're worried about security. On the users, it's really your choice. If you have a few users with low turnover, certificates are probably the safer way to go. Because chances are, if they use passwords, they're going to reuse a password. And if you only have, you and your buddy or a couple of friends, you're not worried about having to issue a few certificates. If you have a lot of users or high turnover of users, that's probably a place that already has some security or password automation method set up. And probably use passwords would be okay. Balance your security with the support man hours. Somebody's got to make a business decision there, whether it's for personal use or not. It's still a balancing act. Subnets. I should have made it bigger. Have a plan before you start.
Really?
Who would have thought?
Start by lining out all the machines that you want to connect to the network. Know what IP you use at home, or what subnet you use at home. Know what IP your buddy or IP subnet your buddy uses at home. If you are working with any businesses, make sure you know all the subnets they would consider using from now until eternity. And do your best to avoid all of that. The 10 dot address space is huge. There's a very good chance you can find somewhere big enough to avoid everybody else. That being said, like the plague, avoid 192.168.0.0 and .1.0. And I'm actually beginning to see some .2.0s now because somebody thought they were being smart. Those are the default subnets in just about all consumer grade wireless routers these days. Anything managed at the consumer level, and too many devices use that. If you leave it there, you're going to have to change it. And if you don't change your own stuff first, you're going to end up with somebody on the network that can't change it.
Oh.
And then
Everybody else on the network is going to be in this subnet starting out.
yes, yeah, as a rule, yes, especially at the consumer level, not necessarily the business level.
But not unlikely, I would think.
What's that?
At the business level?
At the business level, it's probably unlikely.
Oh.
Because anybody reasonably savvy enough to set up their own network will also be avoiding this. And always leave room for expansion, just like line numbers in BASIC.
Oh,
especially if you go with the 10 subnet, it's huge. The Class A 10 subnet, it's huge. Don't worry about it. There will be plenty of room. Start at 10.0. So the next one should be 10.1. Even if you only need a Class C in each one of those subnets, block off big chunks, and you can always fill them in later. And so it's harder to spread stuff apart and have to touch a bunch of machines. Routing, static or dynamic. If you have just a few sites where you only have one hub, one VPN server that everybody's going to connect to, static routing may be just fine. If, on the other hand, you have multiple VPN hubs, especially for redundancy, or you have a lot of users coming and going from your connections, probably some form of dynamic routing would be better. Personally, I use the Quagga routing daemon with OSPF. Probably do a whole talk just on routing and Quagga and OSPF. So really, that's all I'm going to mention it here, unless people have more questions that come up later. And especially on Linux, you may, especially if you use dynamic routing and service IPs, you may have to disable reverse path filtering. It's a method on the kernel that's designed to make sure that you only have packets coming in an interface that are addressed to an address on that interface. If you put your service IP on the loopback address, the packets will come in one of your tap or ton interfaces and get dropped on the floor because the reverse path filter says, hey, they didn't come in an interface that has that IP on it. It's easy to fix. Strangely enough, I had to do it every time I've done production work, except for the time I built a couple of servers this afternoon to make some slides up, and I didn't run into the problem at all. Service IPs. Is there anybody here that doesn't understand the phrase service IP?
Define.
It's an IP that is used for a service instead of a server. So if I have a web server, if I have a web service on port 80, I assign it an IP. I put that IP on a server, and it will serve that address for me. But especially in the enterprise, it allows things like server refreshes, where our website could be 10.10.0.1, and I can put that address on any machine I want. It especially also works with, AIX calls it HACP. Any high availability setups, any failover setups, you've got to have an IP that can float, also called a virtual IP, between the machines that could possibly service that address. In this, I've got a screen or some diagrams on the next page that will hopefully explain some of this. It's absolutely needed in a multiple hub setup action to follow the open path. You should set aside a separate subnet. It's entirely possible this may be a bigger subnet than you're used to handing out. It's much easier if you make this subnet way too big. If you're using service IPs, because it allows connections to follow open paths, you really need dynamic routing of some kind, whether it be OSPF or something else working. And I've always had best luck putting the service IP on the loopback adapter. That way it's always on the machine, regardless of which virtual network interfaces are up or down. So this is how failover with the service IP works and why we should use it. If the user on the left hand, let's talk about the left hand side first. If the user has a route through VPN A and gets to the server via subnet A's IP, then everything's fine until one of those two red X's appear. Well, three red X's appears. And when one of those connections breaks, the user can no longer get to subnet A's IP on the server. At that point, you've got to start your connection all over again to subnet B's IP. Hell, and later on, probably subnet B will go down at some point and have a rinse and repeat. However, if you use a service IP, which sits on the loopback, the routing daemon will handle that. And over on the left, you can see that inside loop that the user would take to get to the server on the left side. And if VPN B or A dies, the routing daemon may take a few seconds, probably will. But if you're using TCP, it won't be within the timeout period. And the traffic will get routed or tunneled through VPN B. But because the user was talking to the server subnet, the server's service IP, it will still know where to go, and the server will still answer it because the server still has that IP on it. It's the same concept as if you had two servers and one server died. You move the service IP over to the other server. This is service. This is a network failure. Any questions on that?
You're saying that service IP could be a public IP of that website.
If it was a public IP, you wouldn't get routed through the VPN. That's why I'm suggesting it's just a separate subnet that you assign one-offs.
Well, the question is how do you do? Okay, so you're saying, I guess I'm cloudy on the use case because what services would you be accessing on internal network? You're talking about, internal stuff?
Yeah, an internal website.
Internal website.
Your Nagios server, an SSH, a server that you only want to SSH into from inside the VPN, your desktop at home, anything like that. Basically, anything that you only want to access from inside the network. You don't want any public access to.
Remind me of that question about desktops.
Sure.
I don't want to take your time now.
Oh, sure. And
I'll probably forget about it if I don't.
let's see, we're at 29 minutes. Yeah, we're doing good. I will, unless we get too bogged down in the next slide, I'll move on to the demonstration part of the program. So network address translation. It's necessary when you're using dynamic routing. You have to source NAT the outbound traffic to the service IP of the endpoint, so that if we go back to this page, even if I have service IP set up, if I don't source NAT it, by default, the kernel will happily assign any packet outbound on subnet A to the subnet A's IP address. If the connection came via the service IP, it will reply via the subnet A address, which will work, but in the event of a network failure, will fail miserably. So what you need to do is, and we'll get to an example of that down later, but what you need to do is you need to set a network address translation for the outbound traffic so that it essentially spoofs the service IP of the endpoint on as traffic goes out the actual virtual adapter. I won't call it a physical adapter, even though the kernel thinks it is. There's also a use case to source NAT all the outbound traffic from a site to hide an internal subnet. If I have two sites and they just want to access services on the other VPN server, you can source NAT all the outbound traffic from your site to the address of your server, and then you don't have to advertise a route back to the original desktop or whoever's using it inside the network. That'll make some more sense when we go on to the demonstration stuff as well. So before we go on to that, because I thought I was going to have to break this up, I have a thank you and question slide.
You mentioned looking at your blind friend desktop.
Yes, I use VNC.
How do you use VNC to look at his desktop as opposed to open the new one? You
So,
log in.
A, it's a Windows machine, and B, with VNC, you could actually, you just specify, even if it was Linux, you would just specify the display number as part of the VNC address for the other machine.
Okay, so assuming he's on the machine, it's probably display 0.
Yeah.
You can VNC to display 0 and then attach that desktop.
Exactly. So, any other questions so far?
That's exactly what you said. Precisely.
So, okay, so, but next you're gonna go on and give us an example of.
Yes. Yes. But that's OpenVPN. What's coming up is OpenVPN specific. If there's any questions on generic VPNs, now would be the time.
Well, yeah, go back then. One more, okay. So the service IP is what's actually being advertised on Subnet A and Subnet B.
Yes, exactly. Because then you have two routes to it. So if one of the routes dies, you can still get to it. Exactly.
Okay. So,
So your shows configuration examples.
Yes. The one thing I will not show is VPN A and B, but I do a one-to-one, but with a service IP in it.
Because I would think that if you have two, a route on A and a route on B, and service IP on the local loopback, how does the kernel decide which way to send it? Isn't it going to show?
OSPF, you set a cost on A, you set a cost on A or B,
Okay.
and then it'll pick one.
They'll try and pick the lowest cost routing.
Or if you're not worried, you can actually get double the bandwidth between the machines, if, or split the traffic load between the two VPN hosts if you set the cost to match, and then it would actually route the packets one for one across whichever interfaces are open at the time. Not much of a use case for that nowadays when connections are pretty fast. Your limit is either your end or the user's end, not necessarily the amount of bandwidth you're allowed to transfer. If you were doing this with two if you did this with two modems, you could actually get double the speed by setting this up.
I haven't used one in 20 years.
I doubt that.
Unless you're talking about the one in the fax machine, I guarantee it.
Actually, it's kind of, it's a neat thing. We've got a couple of and try together something which will be useful to understand. You can actually tether yourself to the global hotspots on two separate telephones. And at that point, man, with words.
So here I am again. I think you all know about me by now. Okay, so this is the OpenVPN portion of the e-think. I will not be wearing a swimsuit, don't worry. No dinner for you. So, OpenVPN is both a client and a server. The same binary runs as a client and a server. It's determined by the configuration files you feed it. And you can have multiple configuration files in the configuration directory, which I will list in a minute. VPN instance is spawned for each config file. This especially is important later if you have multiple VPN instances on the same machine, then we'll look at how to specify a specific interface number. Because if you don't know whichever one comes up first will become 0 or 1. And then when you set up your routing, you don't know which way you want to set up the cost, perhaps. So there's a way to specify a specific device number, not just the device class. And if you're using multiple hubs, if you have multiple connections outside your box, if you're using dynamic routing, you absolutely need to do that. Okay, so one of the things that took me the longest time I could find to get used to was that the same config file in the same format uses 2 different extensions depending on which OS you're on. Linux, the files are stored in etc OpenVPN, hard to forget, and they all end in .conf. When you start the OpenVPN service, anything with a .conf tries to get parsed and processed as a separate instance. In Windows, the config directory is program files, OpenVPN, and fig. And you will forget this. I hope you don't, but I do every time I set this up. You have to change the name of the .conf file to .ovpn. That.
So are you on the Windows version of 64-bit?
Depends which client you install.
Okay, I'll use 64-bit up there.
No, I am percent program files percent, which is a variable based on which version of OS you're running. I was careful to put that in instead of just C:" program files.
Okay. I usually go to the, go ahead.
If you're using this on Windows, set up the OpenVPN service. It will save you a lot of heartache later. The GUI for managing it is a pain if you don't. It is much easier when you're installing it to tell it to install as a service, whether you want it to start automatically or not. It's much easier to set it up as a service, and then you hit Windows, type the word service, hit enter, go to where it says OpenVPN, and you can start or stop or restart to your heart's content. A couple of clicks, you're done. Otherwise, the GUI is, I would argue, pretty much broken if you try to do it manually. For ease of use, you can store the certificates that you're going to need if you're using certificate authentication in the same directory. That saves you from having to type out long path names in the config files and lets you move config sets from one machine to another fairly easily. If you need to rebuild your laptop, you save off the etc OpenVPN directory. When you get your machine rebuilt, you copy it back, and hey presto, everybody's happy. Tunnels versus taps. So we've kind of talked about this. Tunnel is a point-to-point connection. It's an old dial-up connection. It is a point-to-point. It's good for a few connections, but it eats up a /30 subnet for each connection. Doesn't sound like a lot. It's really not in the case of a Class A subnet. But the problem is, if you've got more than a handful, it creates a lot of route table sprawl. If you've got more than a few machines connecting, use tap. God knows why they called it that, other than it may be a reference to vampire taps of days gone by, because it's a point. It appears as a point to multi-point network, essentially an Ethernet cable. So it assumes that everybody is on that same subnet, and then the OpenVPN drivers magically route the traffic where it needs to. Yes, Lee?
Okay, use case for TUN or PUN would be like to a server. Use case for tap, am I assuming that would be where you want to run all your traffic through that server out?
No,
Okay.
that's more to do with routing. We'll get to that in a minute. The use case for tunnel is if you just have a few machines, it's easier, or some clients need one or the other. For example, the Apple devices all come with an OpenVPN client built in, but it only supports a tunnel. So the Android, there's an OpenVPN client on Android. The free version only supports tunnel. If you pay $10 once, you can use tap and you can do some other fancy things. But the free version only supports tunnels. The beauty of it is because you can have multiple config files in a directory, You can have several server instances running on separate ports on the machine. If you're doing this, I would say when you go through the trouble, set up one port that's a cap and one port that's a ton. You'll see there are very few changes you have to make to the config files. And then you just have to remember which one is which when you point a client at it. If you're using certificates, you need some kind of management server. EASY-RSA is the simplest solution for small installs. You'll see it's a one-line install and a couple of pages worth of tutorial. Or if you're a big company or a reasonable company, or you're reasonably paranoid, and you have an existing certificate server, a CA server of some kind, you can use that. You just need to create a certificate, get it signed, and if you have an existing cert server, you know how to do that. You need a certificate pair, that being the public and private key, for each endpoint that wants to connect. And if you're using multiple hubs, I strongly recommend using the same root CA cert for both machines. If you do that, then all the certs issued to your clients will work on either hub or any of the multiple VPN hubs you have. It makes failover a lot easier for the clients. And that way the clients only have one network interface to worry about. The OpenVPN service running behind the scenes will switch over to the other VPN server if there's a failure. Some common configuration options. Yes, I realize these are fairly small for those of you in the back of the room, or Steve. But we'll go through examples of almost all of these later anyway. So port, obviously that's the port number. Proto is TCP or UDP. Your options are pretty much dev tap or dev ton or dev tap number or a dev ton number. And this is where I mentioned you should specify a number if you're using multiple instances on the same machine. So later when you're setting up your routing, you know which one goes where with certainty instead of crossing your fingers based on how they bounce around. CA, there's a CA option, a cert option, and a key option. Pretty obvious what those are. They just point at the CA, the cert, or the key files. There is no key store involved here. You just put the plain file in that directory. There's a server option, which really isn't well named, but the server option specifies the subnet that the server will hand out to the VPN clients. And the ifconfig-pool-persist lists a file name that will store the mappings of client to IP address. If you specify this option, the clients will try to get the same IP address every time they connect. In practice, as long as you don't have more clients than you have IP or subnet space available in that server line, they will always get the same address. For most of us in this room, that probably means, yeah, you're fine. The push route option, this is useful if you're using the service IP subnets, the service IPs that we've been discussing. This pushes a route to the client when he connects that comes back across the VPN with the service IP and subnet, or the service IP subnet and subnet mask, so that anything for the service IPs gets essentially pulled from the clients back into the network for you. You don't have to set up any manual routing. There's a client-to-client option. By default, this is commented out in the config files. This is whether or not the VPN server should allow client-to-client communication. If you have a bunch of VPN clients and you only want them talking to the server that they're connecting to and not to themselves or each other, then you want to leave this uncommon. If you don't care, like I have my house, when I'm at my house, I want to be able to talk to my buddy's house in Connecticut. I turn the client-to-client option on. Comp-LZO, that's compression. It must match between client and server. There's an There's an adaptive option. It does not work. They must match. Your choice. If you're moving a lot of unencrypted data, I suggest turning it on. If all your traffic that's going across those sections, those VPNs is SSH or HTTPS, probably not a lot of benefit. Keep Alive does exactly what it says on the tin. And user and group. In Linux, the OpenVPN server, once it spawns, will attempt to set UID and set GID to those users and groups. Typically, you specify nobody or nobody and no group so that they lose their root privileges in case something ever hacks them. So the demonstration, and we can call it a demonstration loosely, looks like this. So we have a client and a server. The service IP for the server is 10.200.0.1. The server subnet for the VPNs is 10.200.10.0 class C. Because the server is set as a server, it will always assign itself .1, or well, whatever the first IP in that subnet is. And the client will get a number that's not guaranteed. Can be fairly it will be fairly static, but it is not guaranteed, even if you specify that persistent file previously. Because if you run out of IPs, it may have to reassign something. It's essentially DHCP. It behaves just like DHCP. As long as nobody else needs it, we'll keep handing out empty ones until somebody needs to recycle. A giant disclaimer. In the interest of brevity, I have left out a lot of server hardening that should be done if you're doing this for real. I will be SSHing between machines as root. Do not do that. On the other hand, I spun up 2 virtual machines that connect to nothing I care about. And when we are done with tomorrow night, we'll be getting destroyed. So I don't care if I didn't get hacked. I really don't. There's nothing on them except what I needed to create these slides. So this is what they look like. And anybody familiar with that screenshot can tell me where I'm using them. Anybody?
No.
Yeah, exactly. DigitalOcean. So the server, as you can see, is a mere 512 meg machine with a 20 gig disk. It is located in their London data center with an IP, whatever. And the client is in New York City. New York City! With another IP. And again, it's just a 512 meg machine. If I left these running for a month, they would cost me $10. They're guaranteed to have at least a terabyte of transfer per month. DigitalOcean has said they have not run into any bandwidth limits yet, so they are not even bothering to measure the traffic that you use yet. They reserve that right later, but for now, you can use as much as you want. It's stupid, I guess. So the fact that I put the server in London and the client in New York City is important because this goes back to the GEO-LOCATIon demonstration we were talking about, and I'm going to do later. I'm moving over here so I can see things better. It's pretty simple. On the server, you install 2 packages. Maybe 1 if you're using a different CA server. But for my demo, I've got 2 packages to install. For the client, I literally have 1 package to install. I thought about doing screenshots of PuTTY, but I think this suffices. On the server, configure EASY-RSA. You create a Diffie-Hellman, essentially random parameter file. Do that with OpenSL. You write it out to the etc OpenVPN directory. You go into the EASY-RSA directory. You create a keys directory to store stuff. You edit the vars file that's already in that directory. It will have some San Francisco options or something in here. As you can see, I tell you it's all in one chunk in that file. You fill in what makes sense. I think it's pretty obvious at this point. You source the vars file. When you do that, it will spit up a message I have highlighted in red, and it means it. If you run the clean all script that's in that directory, it will do an rm-rf on all the keys. This is good or bad, depending on whether you wanted to do it or not. The first time you're doing the install, you do it because just in case something got left over from a distribution, you want to make sure everybody's nice and clean. And then you run the build CA script. That will spit up those defaults that you set on the previous page. Over here, it will ask you to confirm all of these options, confirm they're correct, or break out, edit that vars file, and run the clean all again, and then run your build CA again until you're happy. Pretty straightforward, really. Create the VPN server certificate. So you will literally run build key server, and of course, since I named my machine server, I put server. It goes through that same chunk of options, and you just keep hitting enter. And then at the bottom, it says the certificate is to be certified until a certain day. The default is 3650, 10 years. If you want to change that, that is a variable in that vars file. It asks you if you want to sign the certificate. Well, why the hell else would we be doing this? And then when it says, okay, I've created the certificate signing request, do I want to commit it? You say yes. And presto, you now have a server.cert and a server.key file. You copy those over to the OpenVPN directory. Here's what the server.conf looks like. Maybe a little small for some people, but everything in there is an option I already talked about. If you're doing this for real, copy the sample one and edit it. There are some other options in there which are not common that you might be interested in, but for the sake of brevity, again, I just put in what I needed to do. And actually, during this demo, these are the actual server.com and client.com files I used. So this is a minimum set if you really wanted to write your own. Port 1194, it's the standard OpenVPN port. I could have picked anything. Protocol UDP, a device that's a tap. If I was doing this for a real server, I would probably put a number on there if I had the routing, but I'm not worried because this is just our demo. The Diffie-Hellman file that you created earlier, you have to specify. So when it rekeys things, it knows some random thing to do. You specify the CA, the server certificate, the server private key, and there's the server line, that 10.200.10.0 with a class C subnet matches the subnet I listed on the top arc on the diagram. I give it an IP or an ifconfig persist file where it can store it. If you're using multiple instances, those need to be distinct files. Personally, I name them with the port number. It's easy to figure out. There's a push route, the route for the service IP subnet for the clients is 10.200.0.0. I'm using 0.1 as the service IP for the server. It's a /24. That's not right. That should say space 255.255.255.0. Force of habit, I suppose. No, it does not. It actually it needs it fully spelled out. Unfortunately, I'll have to remember to change that before tomorrow. That's why I'm not publishing these slides until after I do this tomorrow. The client-to-client option I left on just because I always do. The keep alive, that requires a little bit of discussion. That sends a keep alive packet across the tunnel every 10 seconds and will fail and attempt to restart the tunnel after 120. That's not 120 tries. That's 120 seconds. This is the only place I've ever seen it where that second number is not the number of tries it needs to fail. It's the amount of total time it needs to fail. Everything else I've ever seen that talks about a keep alive says, try this often for this many times. This is this often for this long. So it would try every 10 seconds, and if it fails after 2 minutes, it will reestablish a connection. This also means that if the server goes down, it will continue trying forever. That's in most of the time, especially if you have a site-to-site VPN. You have the service IP to the server. Just doing a simple IP address add. Personally, I just cheat and do that in EASY-RSA.local. Notice it's a /32, and it's on the loopback address. When I run IP address, you can see on the loopback down there in the middle is INET 10.200.01/32. As far as I know, IPv6 works through these tunnels. I have never tried it. I have no reason to believe it wouldn't work though. It's just an encapsulation, so should be happy. You start the OpenVPN server with simply service OpenVPN start. And you wait a few seconds, and if everything's happy, when you run IP address, you'll see a tap 0. You'll see tap 0 because it's the first interface. It's a tap type. And you'll see that it has 10.200.10.1. That's the IP of it picks that, that's the first IP in the subnet. Of course, it creates a default IPv6 address as well. If you get that, you're good to go. If you don't, tail var log syslog and fix what it tells you you did wrong. Lather, rinse, and repeat. Gary, you had something? No? No. Okay. If you've gotten this far, you create some client certificates. It's not build key server, it's just build key. The difference is whether the cert is actually tagged as a server or not. One of the options in the configuration file that I don't describe is you can force it to only connect to client or to a server that presents a server type key. So they couldn't talk to each other if you don't want them to. Again, when you run that build key client, it spits up the same defaults. You hit enter a couple of times. It's all fully familiar, doesn't it? And you say yes, you want to sign the certificate. Yes, you want to commit it. You get CA cert, the same CA cert, the client.cert, and the client.key file. As you can see, again, I'm doing this as a don't do this. You copy those over from the server to the client in Etsy OpenVPN. So far, so good. You configure an OpenVPN client. This is what the client config looks like. You specify a remote. You can specify more than one remote. If you specify more than one remote, it will start at the top of the list and try that until the keep alive expires. It will then roll down the list until it gets to the bottom and starts over. There is also a remote random option if you don't care which of the redundant servers you connect to. Personally, I do because I have different bandwidth limits on the two servers. So I connect to one that is more permissive unless I can only use the other one. Obviously, that's the IP of the server and the port number of the server, what protocol to use, the device type. The device type, for hopefully obvious reasons, has to match whatever device type is configured on that port on the server. So you can not have a ton on the client side and a cap on the server side. That's why I suggest configuring 2 ports on the server, so you can pick one if you have to have a specific device type on the client. If you're using a client that has multiple connections at the same time, you can specify a number after the device so that you can, just like on the server, you can present a consistent tap device or a consistent device address name to the routing protocol. Again, you specify the CA, the cert, and the key, and I keep it alive. As you can see, there's a few less options, but neither one of these config files needs to be that big. This is a little smaller, but basically then you run OpenVPN start. And again, you wait a few seconds, maybe a few more this time, and then you type IP address. You'll get a tap. The tap is 0. And here you can see, hopefully, it got 10.2. Obviously, it will iterate up based on what's available, etc. And then you run IP rep. Now you'll notice besides the obvious routes like a default and your Ethernet interface specific route, you'll have an interface specific route, which is the bottom one on the device for the subnet that you're connected to. And one above it is 10.200. You'll notice that's 0.0. And it goes via 10.200.10.1 on the tap device. That is the route that got pushed from that push command in the server config file that allows you to get to the service IP subnet. Another use case, I have my laptop. I have it set up. You can actually put a route option in the client config if you don't want to push it to all clients. But basically what I do is I have it set up so when I connect, it automatically adds a route to my buddy in Connecticut's subnet. So once I'm connected, I can just go directly to that internal IP address, and OpenVPN sets up a route on that tunnel device. So it just sucks it right across for me. And that works real well because then if I have the OpenVPN, if I'm at home, I go to the same address as if I'm out on the road. I just bring up OpenVPN. I can go to 192.168.99.4, wherever I am.
Are you going to show an example of backhaul and rest of your traffic? Default route?
Changing your default route? No, I don't. Okay. You could. That's a good point. I don't have a demonstration of that, but if you were so inclined, you could then add a static route specifically for the VPN endpoint, and then change your default route so that all traffic then goes through the tunnel. There is actually an option in the config file called default route that will tell it will automatically build that single IP route and then change your default route for you. I don't find much use in that. I personally abhor people that just rip all the traffic back unless they have a really good reason to. We do that here, unfortunately, when I'm VPN'd in.
That's why I'm asking.
Yeah, we do that here. The Gray Bar VPN steals your default route. It's really annoying when you can't get to stuff in your own house anymore.
Well, but still, if you want to use a VPN to pull not YouTube video, but pull media from London so you get around the country code, you have to change your default route so that the browser's going to, or your tools going to do it right.
You could change your default route. I actually went the other way and showed you the slightly more difficult but more specific way of doing it. So if I want to go to YouTube as if I'm in London, I figure out what the IP of the YouTube server is, and then set a specific route for that to go through the VPNs.
Yeah, but that's not always going to work because a lot of times that server's going to want to pull 10 different servers into the fray.
Yes.
And so your main one's in London, your rest of them are going to come from wherever your default route is.
There's another way to do it.
Okay.
And
And you'll have that for tomorrow night, right?
no, but I'll mention it here in a minute. So at that point, you can test the connectivity, ping the other end of the VPN, the device that's tap 0, and if you want, ping the service IP that you gave the other server. Make sure you can get to all the service IPs that you might want to get to. If it doesn't work, kind of on your own. Unfortunately, I can't begin to think of all the ways in which it could break. And salt to taste. There's a very good chance the IP tables command will come in handy here. At this point, you're pretty much ready to implement whatever use case it is you came up with. One of the typical ones would be to extend to multiple VPN hubs, where the beauty of this is if you are willing to use the same CA cert, you can copy Etsy OpenVPN to the new hub, change that server line, so it uses a different server subnet. And you're good to go most times. And then you need to add something to handle routing and some network address translation. So in the next 35 seconds, I will show you the geolocation demo I have. So this is what I chose. So the client's in New York. I ping this lovely server, checkip.dns.org, so I can get an IP address for it. Of course, it has multiple IPs, but I just picked one for the sake of this demo. I wget that website. It presents a very basic page, which just says the current IP address is this. You'll notice that current IP address matches what was on the client earlier, on the VPN or on the DigitalOcean page, but the client wants to appear to come from London. So you configure the server. You allow IP forwarding on the server. You run an IP tables command that says anything coming in, any tapped interface gets marked with an ID of 1. If it keeps going through that server and goes out the other end and is going out in Ethernet of the server to the IP of the server. So then when stuff goes out to the real internet, it knows where to come back to. You change the route on the client. In this case, to Lee's point, I'm pulling a specific route rather than changing the default route. You add a route to that IP, say go through the VPN, and it looks like this. And then when you run the wget again, it comes up with an IP of this, and you'll notice that's the server IP. And yeah, what was the other use case?
Oh, I don't know.
Okay. Glad I put it off. Well, and that's my entire presentation.
I'll think of some more for tomorrow.
That's fine. And thank you. And are there any other questions?
Maybe for tomorrow.
Or later. Or later.
What about the situation where you want that machine, the simplest use case is set the default route. It feeds us to basically a VPN box out to a gateway to the rest of the world. So what happens if, for some reason, your IP changes?
Which IP? The outgoing IP, the Ethernet IP on the server.
Well, no, that's not.
If it changed, if you expected it to change, you could check it and then change that source nav rule in IP tables.
Is there a simple way to do that without automatically?
Fairly simple script.
Or just we put a script in time to crime tab, check it every 10 minutes.
Something like that, yeah. Yeah, that's what I would do.
Well, I'm getting to a specific use case. I'm just trying to figure out if there's a parallel here.
We can talk about it separately. I know you don't use VPNs. I think you should be.
No, I use a virtual environment everyone. Because I'm just looking to get to that machine, whether it's Linux or Windows or Apple.
Yeah.
And I'm just running stuff on that machine, single machine. So they all call into their server in the bat cave. I think we have like 27 or 28 of them now. And yeah, I just use it for that machine. It's a lot simpler for me than setting up a VPN. Because all I do is set up the key, and I don't have to deal with any root authentication, no service level. That's all usually.
Yeah, that falls back into the maybe why not if you're only accessing one IP port. Yeah.
But that's my use case. That's not the standard one.
Yeah. There's like I said, it's infinitely configurable. I'm more than happy to talk about anything later or tomorrow. And that's about it. Thanks.
Thank you, Chuck. We had kind of a scheduling mix-up here. If you remember last month, we had Bill Odom scheduled to do a tutorial basic session on Vim, and Bill wasn't feeling well that day, so he had to beg off. And I originally said, okay, well, we'll put his reschedule for this month. And then we realized that Bill had another commitment, which I'll mention, we'll all know about here in a second. So kind of, we started juggling the schedule at the last minute. And so Chuck thought he was doing the full long presentation tonight. And then at the same time, we scheduled Steve to do the main part of the presentation tonight. And so Chuck divided his in half here in just the last couple days of quick editing. So a lot of last minute editing here by these two guys. So thank you both for trying to accommodate us. That's not a desperate.
Yeah, but I couldn't have come 2.5 hours.
So anyway, let's see. You mentioned Tor at one point, which is an interesting thing.
I'm just gonna keep doing that because that's fun.
I did a presentation on about 3 years ago.
I'll find my mouse. Your mouse.
It's right in the middle of the table.
Yeah.
Where you use the mouse.
Oh.
Mouse.
Oh, how quaint. Thank you, Scotty. Anybody left?
Hold on.
Sorry about that.
Hold on, Gary. I'll just pull. Now you can, Gary. Now you can use the mouse on this screen and it's that. At the same time.
At the same time. Okay. I was just wondering if anybody did anything or do anything about this Tor blackout strike. I don't know all the details here. What was declared? This is, I guess, about a couple of weeks before the September 1 date. Somebody declared this strike on Tor. Anybody hear anything? Read anything about it?
Can you make the text bigger so that you can see it on the camera?
Control.
Much better.
The basics of it is some social justice. A large number of people didn't like the product or project. One of the main project developers that lives in Germany, and started digging into things and realized that Tor was written by the U.S. government. And
yeah, what's surprising about that? We've known that for years.
yeah, well, they're social justice warriors, so anything's a surprise to them. So at that point, they decided to call for a strike. At which point, everybody laughed at them, and as far as I know, nothing serious ever happened from it.
It's kind of
A very quick note: if you want to use Tor, don't. There's very little use for it. Almost none of it's legitimate. There are plenty, if you really want something anonymous, there are plenty of other VPN services out there that offer anonymous browsing that will throw their logs away as soon as people connect to them and such things. Tor is a way for the government to make people think they're secure, but they're really not.
There is one specific
I'm sorry, say again.
Speak up.
If you're trying to get around certain types of security, where they're trying to trace your packets back to you, it's still exactly can't do this.
Well, that you can also use one of the anonymous VPNs or a couple of layers of
Yeah,
that.
but then people, if you're in China, then you have problems with the control of the system.
Yeah, well, they're going to block most of the Tor stuff unless you're smart enough to get around it anyway. If you're smart enough to get Tor out, then you're smart enough to get something better out too.
By the way, I should have asked already. How many people have like general questions, not pertaining to one of tonight's talks, that they want to throw out here? They've got no Q&A.
I wanted to mention, this is more of an announcement than a question. Lightspeed 2000 equipment is being installed in my block right now. Funny. Is anybody else aware of this? Know what it is? AT&T gigabit optical optical fiber.
Yeah, but it's
It's AT&T.
Was it wireless service?
No, it's, I think it's
Fiber to the home, isn't it?
fiber to the home.
Google just announced they were gonna come into St. Louis or what?
I would imagine that would,
Seems like every time.
Or they're afraid it's gonna be
they might
announced.
announce it. Yeah. But anyway, they're digging up the strips between the curb and the sidewalk to lay it down. And then they're, I guess when subscribers sign up for it, they'll
Trench it in.
trench it into the house. And I talked to the guy this afternoon, and apparently it's actually strung from poles until about a block or so away. So it's still subject to ice storms and stuff. I was thinking, bury it all and we won't have an ice storm problem, but it's on the pole.
And it's a lot more expensive.
The buried is more expensive than it's broken.
It depends what natural disaster you're trying to protect from.
Well, the
Earthquakes,
backhoes are their big problem.
backhoes.
Floods.
Some guy tries to dig out and put in these sprinklers,
Mhm.
and they end up cracking a piece of fiber. If it's 6 feet under, then they got to trench a fairly long distance, fairly deep to repair it. Whereas if it's on a phone pole, some guys just drive it and repair it.
And we were wondering why they aren't just hanging it on the poles in the back of their house.
With
Uh,
physical damage, fiber is more subject to being physically damaged than copper is.
So
You get a
having
really nice big windstorm, and all that stuff is flapping around and shatter a cable. Whereas it was the electrical has problems with electrostatics when it gets bounced around like that, because if a communications cable, that isn't such a big issue. But if you whack the fiber, crack it,
it can shatter.
and that's a big
So having that on a pole a block away, that's going to be a more stabilized.
It's gonna be a thicker cable.
A
It's gonna be a
thicker
thicker
cable.
fiber.
big stiff outer layer that is inside.
But it could be a cost issue too, with this light speed, they may not have the rights to those poles.
The guy and I were kind of wondering if that was the case. I mean, they've got the twisted pair line up there, but then you add another wire and it's going to be additional right away.
Well, might be right away, and also, anyone double check the crack that got hung off the pole.
Well, that was what we were,
You could also get to the point where you get a structural limit on the poles.
because we've
Because
got,
again, you got wind load issues, if you hang that nice big thing. It's not that they don't have the rights to it, but they might not feel like pulling down the pair in order to put up new stuff.
because you add more weight, you need to take every way
Yeah,
down.
and the physical wind load, you can snap it all.
Because we got the cable connection, we've got the existing twisted pair bundle, we've got the power lines.
Just a few things.
I don't think there's anything else.
Well, the other,
Typically not.
the holes in the alley are easily reached by some immediate climate. Whereas the main poles, maybe through fares.
So,
Yeah.
so it was interesting, watch all the fun equipment, and we've got tomorrow, I think they're gonna do the thing that pushes the cable, the horizontal drill thing. He was parking it this afternoon. There's a guy with a remote control. It's like a drone. He steers this thing around. It has a seat on it for when you're drilling, but for moving it to a new place.
Right, so when you're drilling, you take your own walk out there where you're going. A lot of times you have a locator that'll
Yeah.
confirm exactly where it is. That's about time AT&T has been losing business for the last 5 years because they can't touch charter.
Yeah, it was like jumping from not nearly as fast to
Fast.
really fast.
Which, by the way, one of the ways they're trying to get customers back was after the Apple announcement last week with the iPhone 7. They announced that now if you do a new install of UVerse internet service, well, I shouldn't say just internet, but if you do some AT&T install, whether it's voice, data, or television, or all three, or combination, you get a free iPhone 7.
That means service.
No,
No, I mean, you get the box, you get the device and,
you get the device.
oh, and then you pay for service on top of that.
Yeah, you gotta pay for service, but,
Now, if they're getting on Android, not
but
Exercise on whatever new model.
but the fun thing is I know some people,
Well, that's it.
I know some people who've already tried to get that, and as usual with corporate screw-ups, they haven't told the minions about it yet. So you call the person to place your order, and the person on the phone is saying, "Pre-iPhone 7." What? Let me talk to my manager here.
Samsung said their replacement thing, I guess, gracefully, they have all that figured.
Anyway, moving on to other things.
I got a
I got an
trivia.
announcement.
Yes, Phil.
It's not computer related, but a friend of mine that's very active in ham radio says they have a conference for microwave guys,
Uh-huh.
and that's going to be next month. So I got cards here for you guys interested.
Where's it gonna be?
It's going to be over in our city. Got one hotel over there.
And amateur service in the microwave band?
Yeah, it's, just about the guys that are always dealing with microwave stuff.
That'd be great.
So, if you're interested or whatever, I got plenty of cards there.
Sounds like fun.
That on its way.
Roll it down in front of me too.
I was
Yes.
gonna say, I closed down the presentation, that probably gives a
Does
bit.
any financial institution offer VPN?
There any,
Financial institution, bank, offer VPN for the customer?
There would be very little use for it that wouldn't be served by using an SSL connection to the website.
Yeah, so,
That's my big problem. 30 years ago, I got that advanced license, I never could use it because you can't encrypt the traffic. You encrypt the traffic.
on an advanced license.
Yeah.
No, on any amateur.
Well, on a hand license, yeah.
what are you talking about, Lee?
What?
You're not allowed to encrypt traffic
On
over
a, on
amateur
an
band.
amateur license.
Yeah, he's talking about doing a VPN to a bank.
We
Or
switched back
financial
around. We came full circle.
Okay, so what was the answer to this question?
There is very little I can't think of any use that wouldn't be equally served by just using an SSL connection to their website.
That makes
If
sense.
you could think of a use besides hitting their website, I'd love to hear it. But it's the same, it's open it's SSL, it's the same encryption that you're
Oh,
using to go to
but-
the website.
You're saying set up a VPN to a bank website?
Or, yeah.
Well, you couldn't do it, because you don't have access to that.
Well, he's saying, are there any banks that offer it? Are there any banks that will give you a cert to connect to their network?
Well, for employees who are going to do work at the bank,
I think
Yeah.
that would violate PCI standards pretty quick.
yeah.
Most likely.
Yeah, you wouldn't want the users on the internal network.
Well, you
Yeah.
actually would, you might have, you were trading from, it was pushing enough sensitive data, and you had a dedicated line bank.
Well, that's
For example, a hedge fund, well, you're saying customers. There, for any one of us doing our online banking, if you're a hedge fund or a commercial trading outfit,
You're gonna have a server in the exchange.
well, what I'm saying, you're gonna have, but they're also gonna have a server in the bank to access your funds. And they might give you a VPN into a private server
Into a subnet.
on their NAT, so that the point there is that the VPN terminates inside your bastion host. And you can encrypt it going further in, it's stopping at the wall, someone that compromises an outer machine that goes through traffic. So the one advantage there is you can have the VPN terminate multiple layers into the security. And that way people who want to look at your stuff they have to penetrate multiple layers of security to see you. But they're not gonna do that for
Consumers.
Joe Blow off the street. You're gonna have to be someone who's got, or involved.
moving on, this falls under a personal gripe of mine. Years ago when I was doing the statistical analysis at the university, in charge of it, I always forced people doing their dissertations to you have to do your statistics in more than one package and do more than one sets of approaches to the data. And usually got booed and hissed because it's like I'm some kind of an anal fool having this. It's going to come out with the same result. I mean, it's just be using a different package.
Should.
Yeah.
Say the result.
Should,
That
yes.
doesn't mean it will.
Exactly. Yes, that was my point. And so here, this last month, back on August the 23rd, there was this little news article that came out that basically 20% of the scientific papers on genetics contain conversion errors that have been caused by Excel.
One more reason.
Well, yes.
What's the feature?
Hopefully those were none of my former students who put the papers out, but yes.
Hopefully it wasn't the people trying to deal with your genetics to see if you got a problem.
That does kind of worry you, doesn't it? So, but yes, this is why you try and duplicate experiments and make sure that you come up with the same results. It's amazing. Yes, you should come up with the same results. But
Well, I don't know, it doesn't prove that people don't screw things up multiple times, but at least it's novel ways.
Novel ways, yes. Let's see, some other just fun dates. Let's see. 1985, Steve Jobs got out. Let's see, where is that here? Hold on. Is that next month? Yeah, 1985, Steve Jobs left Apple for, I think it was a dozen years. And then in 2001, just a couple of weeks later here, after he's back, you get OS 10 at Apple, which is basically his next project that got brought over. So yeah, after he came back, it only took him less than a couple of years to get next becoming OS 10.
And last I looked, you can still see fossils of Next all through the
Code.
all through the code.
I'll do it there. Yep.
Oh, speaking of which, Gary,
Yeah.
2010 LibreOffice 4. What's that?
Yes, in 2010, that was
Oh,
what,
from OpenOffice.
from OpenOffice, yeah.
I thought you meant semi-core LibreOffice in one of the three.
Nope, but that was the
That was
split.
when Libra was born.
Yeah, when Libra was born. So, kind of a similar line. Let's see. Linux kernel. First Linux kernel was released in 1991, but the birthday was actually, if you remember, celebrated like 3 weeks ago, 3 weeks and 2 days ago, which shows you just how fast things happen. Linus put out basically an RFC on what was then a news group
Compost Minix.
and it took all of just over 3 weeks before the first version of the kernel wound up coming out. Last year, it kind of goes to your talk tonight, Steve, and maybe you can make some comments about it during your talk.
USBs, yeah.
Yeah, well, last year at this time, or on the 20th of September last year, AWS failed, screwed up Netflix, Tinder, IMDb, a number of other users. Cloud
Apocalypse?
Yeah.
Or it should be Cloudocalypse.
It's amazing what the newspapers can call this.
Yeah.
And that goes to my point about having multiple VPN hubs.
Yes. Yes.
For an extra $5 a month, it's cheap insurance.
See, coming up this week, Strange Loop starts tomorrow. Actually, Strange Loop starts Friday.
Tomorrow's the freeze. I'm the people, what's my follows group? The Papers We Love.
Papers We Love.
I'm going to be photographing them tomorrow, but if anyone's got any time, if you look around, there are a whole bunch of pre-loop events for different groups that are using the space. The Papers that I love is just one of them.
And if you correct me if I'm wrong, as far as I know, for the main conference, tickets have been sold out. I'm not sure on the pre-conference, but
I got a free ticket because I photographed
Right.
these guys. So,
Oh,
no idea.
So
I,
you won't be an army anymore then?
and I,
Right.
Oh God, we have had this conversation again.
yeah. I believe, well, these are mostly during the day, but tomorrow, during the day, the coding dojos, there's one in the morning, one in the afternoon. If somebody had a better way of describing that, I'll give it to you in a second to describe, but they don't require a paid ticket. You just show up down there tomorrow if you want to go to one of the coding dojos or both. So you can get in on that. Anybody got a good, quick description of what a coder dojo is? I guess the way it's been described to me is it's basically like a quasi-mentor, a gym for learning how to code. I mean, you go in there, you bring your laptop, and it's like, okay, let's work on this now. Okay, Steven, turn out another 20 lines of code that do this. Lee, give me another subroutine. So it's just kind of forcing you to sit down and do something. And so there's actually a group that's starting every second Saturday coder dojo here in St. Louis. But this one is just connected to Strange Loop tomorrow. Apparently it's
Open for discussion?
right. So I believe we're good in this. I don't think they specify.
What have these over language calls?
So that last paragraph up there. Up. There's so many new languages to learn about at Strange Loop. This is your chance to kind of try them out. Programmers follow a pattern similar to martial arts dojo to practice their skills. You'll get an opportunity to practice new languages with leading experts on hand. We'll be using Randori mobbing format. Let as many participants as possible do actual coding. But it still doesn't say, it just sounds like you'll be exposed.
Well, it's basically, they bring in a number of experts in X number of languages, and you pick one.
Better blow the guard when you leave.
So yeah, if you're interested in learning to code some new language, tomorrow may be your shot. Next week on Tuesday, the DevOps group usually meets over here on Thursday. I haven't marked that yet. That needs to be marked to say they put out a message saying, go to the Tuesday meeting. DevOps is going to meet with the Docker group, but it's actually the same meeting. But one is just a placeholder for the DevOps people who want to join this one. But there's a Docker meeting next Tuesday. So
What's the topic? Scroll down. That's a scroll, okay.
Productionalizing, what a word.
goes on quite a
A
bit.
big question using Docker was, a couple of years ago, perhaps, on Docker was plural. And if there was looking at the crack that you put in a container, really need all of it once, just to, consider the time. There would be ways reducing the amount of garbage, putting people out of use. Back down to the point, get out and throw it only the library on it, the application that you're using. And then we can fix that after that. It was a very interesting area. So that's how it is.
Question here.
Yes.
Is there going to be an after meeting?
Tonight?
Or tomorrow,
Oh, tonight.
or both.
We're open to proposals.
Well, yeah, I'll throw it out.
I'm certain it is.
Anybody got a suggestion as to where?
If you actually want your, about the only choice that's going to be open at that hour is going to be next door.
Uh,
Well, Denny's is 24/7.
Yeah, but they don't have beer.
Well, okay. So it's one like
That's what I'm saying. If you want beer, you're around here, you're pretty much your only choice is Hooters. If you don't want beer, I would say the easiest place is the Denny's we went to last month.
So we need to arrive at a consensus on which one to go to.
I have a lot of places in South Carolina. It's glassware.
Okay, well, let's see, how many beer, how many want to go to beer, and then we'll vote on how many to Denny's. Beer? Hold up a hand. Okay, and Denny's? Looks like Denny's wins, so.
Does anybody not know where we're talking about?
People have been to Denny's before.
I know, but
Yeah,
we had people that actually needed maps last month.
Wasn't one Denny's nearby.
Yeah, Dorset.
Dorset and 270.
I like bandanas. I like bandanas.
Midland, on Midland, Midland at Lindbergh. So I have a trivia question relating to my bio and one of the topics that came up tonight. Does anybody know what Sprint means?
What?
The telephone company Sprint. Does anybody know what it means?
It's an acronym?
Yes, it is.
Oh.
That's why it was always spelled in all caps.
Oh. I didn't know it was an acronym.
Something diabolical, I'm sure.
No, it was actually a result of a naming contest inside the company at the time. Okay, well, we'll start with Phil Anschutz, who is the owner of, let's see that, Denver Nuggets, the Colorado Avalanche.
Yeah.
The Denver and Rio Grande Western bought the Southern Pacific Railroad when the Southern Pacific went bankrupt, and then renamed itself to the Southern Pacific. Phil Anschutz had a great vision and realized that there was plenty of miles of railroad that he owned, that he had strung fiber along to connect all the signals, because it was the cheapest way to do it when he buried all the old telegraph poles. So at one point they decided to start selling long distance service.
Southern Pacific.
Regional.
You're getting there. So
Regional?
he held a naming contest. Southern Pacific
Regional.
Railroad
Railroad.
Internet?
Internal Telephone.
Internal telephone.
Yes. It was their internal.
Not for retail sale then.
No, but
Wow.
No. That was, as he spun it off, it was originally used as the Southern Pacific Railroad internal telephone system. So when they spun it off, they called it Sprint.
Uh-huh.
And that ties to my bio, because after Sprint merged with Nextel, they were forced to spin off their
But
landline.
that's not the right acronym.
What?
Internal telephone system isn't NT.
IN for internal, T for telephone, or INT for internal. Take your pick.
Oh,
Which ties into my bio, because Sprint and Nextel merged, and when they merged, the government forced them to spin off their old landline division, which became Embark, which I went to work for 9 months after I got laid off from IBM when they folded up e-business.
Okay, we're running way behind time here, so Steve's obviously gonna try and get us going here quickly. Stephen Lembark, he's been here
Hi.
a number of times, he's speaker. Everybody said, hi, Stephen.
Recovering.
Recovering my
Makes it work on the touchpad, or just get it more right things. The touchpad doesn't work. No, that's why I have a mouse there.
Okay, so Stephen runs his own consulting firm called Workhorse Consulting. Workhorse Computing, excuse me. So he's been around town here for a number of years, but he has a lot of clients out of town, and he's also the leader of the Pearl Mongers group here in St. Louis. So you frequently, if you're not hearing him speak here, you'll hear him speak at the Pearl Mongers group. He's also been involved with a few of the other groups around town. And you said next week the Pearl Mongers meeting is about what?
Well, last month everyone sat down and we actually got some, what was it,
S4N? I don't remember the name of the bloody software. It's been a long day. We got some fairly decent podcasting software installed.
Podcast.
So this month we're trying to actually podcast something.
Cool.
So I managed to log in with this stupid thing.
I found the Bandanas website, they're open till 9.
We ain't gonna make that.
Yeah.
Okay.
Can you explain to me why it isn't clicking login and it doesn't give me a login file?
No.
Okay.
It's Windows, what do you expect?
Or it's more to the point, it's LinkedIn. What do you expect?
Tell you what, you work with that if you could with him. And
Here,
okay, a few people have already run out and taken a quick bathroom or a drink
be
break.
forewarned, the floor out there is tremendously slippery.
So if anybody wants to run out and do a quick, very quick break,
How
like I
about
said,
walk carefully?
walk carefully. Yes, don't run out. Walk carefully. We'll get this working in probably less than 2 minutes. So hurry
Well,
back.
it's just if I can't, okay, here now I can finally log in.
Something a tree or 5.
Well, there's 2 versions of this. One, if I do it right, I just want to see which of these has the second half of it. Oh, there we go. That's the version I wanted. If anyone has a chance, actually, this is the one chance you had to see Damian Conway speak at YAPSI. Is he and I split the stage, and we're in full screen mode. So as long as this thing will page down, I can get to talk. Okay, I'm gonna have to stand here. Yep. Okay.
Which for maybe can't go.
No,
Use
it's not.
use the left or right arrow.
Oh, there we go. Okay. Either way, I gotta stand here. Good enough.
Or take the mouse, it's wireless.
Oh, okay. But then I have to be in the right spot. Anyway, once we're ready. Oh, people get back. Oh, man.
Put head on this and shush at the same time. See if I can hurt them back.
Yeah, if you look me up on at YAPSI NA 2016, I got through about halfway through this when I screamed out, I bet even Damian Conway couldn't come up with a better solution than this. And of course, he was standing in the back of the room and said, I'll take that challenge. So he walks up and he reaches, he had a spare clicker in his pocket, and he clicks and advances, and the whole screen dissolves and reassembles itself into his slides. So I'm not going to try and fake the Australian accent tonight. You're lucky. But the whole point of this was showing how to do some of this in the newest version of Perl 6 called Rakudo. Is the implementation, which I forgot what it means in Japanese. So the trick here is showing you how to do something. This is actually a neat technique for a variety of tasks in heavy-duty computing. And it shows you how to do some things that most functional programming languages tell you, the great reason for using FP closure or Scala is they do these. And you can actually do it more flexibly and more easily in Perl. Oh, God, so let us see where people are. Oh. You don't get scared by the slide count. A lot of these are progressive slides, so I got through it.
There's software now too.
For mine. SMB, does that sound right? Yeah. I can, if you want to find out, come Wednesday. Standing here right now, after getting up early this morning and not sleeping much last night, I have bloody well forgotten. I know that if I look on my notebook, there's a symlink in my home directory for podcast-software to opt-bin something, and whatever it's on the other end of that, I'll be more than happy to tell you. But I think for a lot of the groups, we compete so much for people and time and everything else around here. And a lot of groups in different places. It'd be neat if we just recorded more of this, and maybe if more of the decent talks could be reused. For example, if some weird guy like the Unix users group had to pull a speaker out of his hat, you got a projector here, just go click. The YAPC does a pretty good job because they put the slides and the person. The downside is they've got this little narrow strip for the person, and I tend to move around a lot, so I'm off the camera half the time. Just standing there in one place going, "Hi, I'm reading slides to you." There's actually one useful talk, and I've been through Damian Conway's presentation on Aikido. And the Aikido technique is if someone punches you, you don't just stop them, you step out of the way and say, "Please, keep going, slam into the wall if you feel like it."
Or fall over.
Well, and then, just if they want to go past you, feel right. And he has a lot of people fly him all over the world to teach how to present stuff. There's one reason no one's stupid enough to speak when he's going, because everyone's going to speak. So it's a neat class that would be helpful if you're trying to attract people to speak to useful techniques. Anyway, now that we're all here, hi, I'm Steve, and I'm a nerd. Oh, wrong group. But this is a talk I gave at YAPC, and people heard I gave it. Halfway through, the slides will switch, and we'll see how much of it I get through. But this is partly about functional programming. I'm using an example from Amazon, their Glacier service, to show how the functional programming works. And there was spaghetti code. Everyone here has seen spaghetti code? Yeah. Okay. Yeah. Oh, yeah. Spaghetti code exists in every language, in every shape, every time. There's functional. There's object. You name it. There's always more spaghetti in the universe. Theory, if I could pick this up well enough, I could just use the clicker. And then we created objects. And then objects were supposed to solve the problem because you encapsulated everything. And you made it different. Well, what do we end up with? We have spaghetti objects. This object extends this thing. Done. It doesn't. I have no idea what it does. I just know that you extended something by one little notch. I don't know how it works, and I look at the thing below and says, "Oh, this is derived from that thing." And, you go nuts. Anyway, we've all been there. So functional programming, the basic idea, and there aren't many to it, is about transparency, consistency, and the idea behind the transparency was the way to avoid spaghetti is to expose it. Once you see the cockroaches, you start to deal with them. As long as they're on the walls, no one thinks about it. And the consistency is mainly about the fact that data cannot change. Data is fixed. So if you look in functional programming, all of the data is fixed. Once you assign something, you can never modify it. So there aren't, for example, regular expressions that will change something. You can extract and create new copies of things. And there's a downside to that I'll get into later. But for a lot of things, it does work pretty well. If you think of the times you were really banging your head out trying to debug something, these solve a lot of the worst problems. Constant data. How many people have been in the middle of something and somebody changed the wrong value in the code somewhere and it went into a call and something came out and a piece was different and you had no idea how or why? Changing things is where most of us blow it. Transforms, when you modify something. Encapsulation says, I'm going to put something inside this black box, and since nobody ever makes mistakes, it'll come out right. Well, people make mistakes. So if I can see what's happening, if I design the code so that the modifications are exposed, it becomes easier to track what happens. One of the things Functional programming says that all functions require input, and all functions will return the same result for a given output. That's part of the functional part of it. So you see, we've all seen this. You have a method call, you have object points to method, and something comes back. You've got no idea how or why. You've got no idea what part of the object was used to make the decision. So it makes it really hard to figure out what to put into the object to get what you want out. Side effects, you see a lot of these when you're dealing with code where somebody changes something and the classic example is you're doing some accounting software, shopping cart, and somebody adds, and instead of just incrementing the shopping cart and handing it back, they increment the total. But the guy who takes stuff out of the shopping cart just removes the thing and doesn't decrement the total. That decrement was a side effect. I put something in the box, and instead of saying, okay, when I need to calculate the total, I'll add everything up, you do two things at once, and you've got this side effect of adding a new item to your box. Well, the side effects are what fry you. If you have internal state inside of your subroutine, a lot of times mismanaging the state is the most common error people make. So trying to get away from those doesn't always work. And here are some of my favorites. If time returned the same value, it would be ANSI compliant. How many people have here read Clogger, the standard C library? You can write a perfectly ANSI C compliant time function that returns time t of 0. That's your best estimate of the current system time. It's not very useful, but it's legal. Face it, if random returned exactly the same value every time you used it, it wouldn't be very random. If readline returned always the same answer every time you typed yes, it typed whatever you typed the first time, I don't know. It wouldn't be very useful. The whole point of these things, if a database, if every time you ask the query, you always got the same answer. Even if you're asking for the next record on a list, you always got the first record because it's the only thing it can return. State is important. So functional programming has all these twists and turns, but where it works, it's actually pretty effective. So the rule is apply some realities to most of what the people say. Here's one, and I'm going to give one example here that's useful for people. If people know what Glacier is, the Amazon service? Only a couple of nods. So the basic idea, 1 penny per gigabyte per month with discounts for exabytes and petabytes. So you can store a terabyte of backups for $10. The point is that you don't get to it quickly. You can move as much as you want in for free, but you're limited to how much you can move out for free, although it isn't very expensive to move it. You cannot delete things quickly. Basically what they have are tape libraries the size of multiple football fields. And they just use automatic indexing to put your stuff on tape. They stream it onto tape blocks. When you want to get something back, they move enough tape that they get it back.
So Glacier describes the speed. It is glacial.
Also, it's about cold data, long-term storage of cold data. Think of the mastodons that the czars were eating 1,000 years after they died. It's about data that you really never want to get back. It's old tax records, it's backups, it's the Broad Institute putting all of their gene sequences somewhere so that if half their disk drives fry, they don't have to resequence everything.
Ideally, you'll never recover it. But
it's data you probably don't want or you probably won't access most of at once. So for example, I use it for backups of my photography. I'll probably never use them. I hope I'll never use them. But for, less than $5 a month, I can stick all of it out there where I can get to it with a key press. It's not a bad thing. Now, one of the things about Glacier is there are no GUIs for it. Amazon doesn't provide any. You can buy some. But you have to do all of the computing to move things around yourself. There isn't an Amazon service where you can just click stuff and push things around. So one of the interesting things you've got is, let's say I'm uploading a petabyte of data. I probably want to chunk it. I don't want to get through 80% of this and find out that a packet was lost and I've got to start over. So you're going to break the uploads into chunks. And I want an algorithm that allows me to process all of the data exactly the same way, regardless if it's chunked and regardless of the chunk sizes. How do we do that? So the rules here are, you want to let's say you want to upload 10 gig, 100 gig, terabyte. You break the whole thing into multiples of powers of 2 of 1 megabyte. Meg, 16 meg, 32 meg, 128 meg, whatever. But your chunks have to be powers of 2 multiples of a megabyte, except for the last chunk, which will be the runt that makes up whatever your margin is. For every single 1 meg chunk that goes into these, you compute an SHA-256. That's the start of all of this. Then you digest all the pairs and the pairs and the pairs and the pairs and the pairs until you get 1 value. This works because if I upload 1 file, I send 1 digest and I'm done. If I take a terabyte and break it into 4 meg chunks, I get 1 4 meg sized SHA-256 that was made out of 4 and then 2 and then 1. I can ship those off to Amazon. And they can continue doing all the pairs until they get 1 value when I'm done uploading all of it. If I upload 128 meg, I start by taking every 1 megabyte. I get an SHA-256. I digest them in pairs up to 128 meg, and I ship those up to Amazon. They verify each of my 128 meg chunks by SHAing their own, every megabyte, every pair and pair and pair. And then they take all the ones they get and they digest them all the pairs. The algorithm for computing the final digest is the same no matter what the chunk size is for all the legal chunk sizes, because I'm always going to get a power of 2. I'm always going to get that same tree. I'm always going to get a certain number of these things, and I take the pairs when I'm done. So what you get is a process that looks like this. So let's say I'm doing this as a single file upload. I'll get an SHA for each megabyte and 1 at the end for whatever's left. And then let's say I'm uploading this as 1 file. I'll take every pair of these, and when there comes, when this comes to an even number, I'll merge it in, and I get 1 at the top. On their end, they SHA every megabyte. They do all the pairs, and they get 1 at the top. But let's say I decided to chunk this in 2 meg units. I'd have this, I'd do mine, I'd send this SHA with these 2 meg, I'd send this one with these 2 meg, I'd send that one with these 2 meg, I'd send this by itself, and the same algorithm gets them the number at the top. If this was a terabyte and there were 1,000 of these, you compute as many as it takes to get to, let's say you're using 8 meg chunk. You've got 8 1 meg chunks, you SHA them. You take the 8, you get 4, you get 2, you get 1. That 1 SHA that was a digest from the 8 meg you're chunking it at, 8 meg, they continue the process up to the top. So you can start to see, though, if you're doing a large number of chunks, you get a lot of these. Now, this is an example of the Perl code from an existing module that uses an iterative approach to try and compute the chunks. So it computes them all, and then it pushes a stack, and it walks down its own stack. Does anyone really want to tell me what that does in a short amount of time? Yeah. Okay. So the thing you think about is why this is complicated, because trees are a pain in the butt to process iteratively. Trees are naturally recursive. So it would be neat if I'm computing these things, if I could find a better way that's recursive. So let's say the approach I use is I'm going to split up the buffer and make the SHAs, and then I'll recurse down the tree to get all the values. So I can get some Perl that looks like this. If you give me an empty list, you'll get nothing back. But if people have seen Perl, If the stack has more than one item on it, I keep going. Otherwise, return what's on the stack. I've got one item, it's the SHA, and I'm finished. Otherwise, I know one thing. I've got to compute this many hashes. Because I'm for each pair plus one maybe odd one at the end, I'm going to have to compute that many. I can splice two items off. If there are more than two items, excuse me, if there's more than one item on the stack, take the first two, SHA them as a pair, and put that back. If there aren't, just take it as is. And this will compute the SHA. It'll compute the final tree hash. But there's a problem. You eat stack for breakfast. Imagine you're trying to do 10 terabytes in 1 meg chunks. And you've got a few thousand of these to begin with, and then another 500, another 256. You're recursing. You're pushing you're leaving all your old stuff on the stack. You're going to chew through memory very quickly. You have all kinds of problems. That's what those guys doing the iterative approach were trying to avoid by not recursing, was to be able to recycle the memory they were using. 10 recursion is what happens when you call yourself at the end of the subroutine. This is common in Linux kernel programming. It's common in a lot of areas where you're going to go through something, get to a point, and then call yourself again to finish the next step. The very last thing that you do is call yourself. And tail call elimination is the word for trying to recycle that stack space so that it doesn't shoot you in the foot. And there are, anyone here done any functional programming? I should have asked that at the beginning. It's, well, a lot of functional programming, Clojure, Scala, they hark about, yeah, you can reuse the stack. You have one item. As long as you take one item off the stack exactly and put one item back and call yourself, we'll manage all the rest of it magically with linked lists. The problem is that's useless with this technique because you got to take 2 items off the stack each time you do something. Actually, you got to empty the stack. So the fold, which is a technique for recycling that stack space, this is what it looks like in Perl. What you do, you start by saying, look, if there's more than one thing on the stack, I'm done. Hand it back. Otherwise, take whatever my new computation is and assign it to the stack. Perl leaves the stack exposed to you. It's @_. At that point, there's a thing called sub, which was introduced in 5.16, that allows you to create anonymous subroutines that can call themselves if you want to. Sub is defined when you're compiling. Bingo. I can go in, I take the stack, I reassign it. I use it up, put something new there, and go back to the top. I only have one copy of the stack. As long as eventually, as long as I'm doing something that reduces the size of the stack, I'll finish. Because I'll eventually chew the stack down, so there's only one item left on it. So here's an example of computing the tree hash for Amazon that recycles the stack that doesn't blow up. And again, I know what my count is. It's going to be, I'm going to have 2 items plus maybe one odd one at the end. For each one, I'm going to take 2 things off the stack, SHA the 2 of them, and I'm going to assign the result to the new stack. I'll replace the stack in one pass. Well, now the first stack might have 1,000 items on it. I take all the pairs off. The stack's got now 500 items on, and I go back to the top. I fall through. I take 500 to 250. Keeps counting down. Eventually, there's one item, and I haven't wasted all of that space. I get it done with. The problem is, assigning it to @_ gives a lot of people the heebie-jeebies. They feel like they're doing something unnatural with the language. And goto makes a lot of people run screaming out of the room.
Mm-hmm.
Goto in Perl isn't what you did. You can only go to a subroutine. You can't go to a line number anyway. But what this basically says is restart the call without reassigning the stack. That's all it does. There's a new word for it in Perl 6 called become. So if you want to become yourself, you just recycle the stack. So what I'm going to do here is I'm going to show you a way in Perl. Now, this is a general technique for not having to write as much code. Keyword declare, when you use it, you're not creating, in a lot of language you create like lambdas, you create little anonymous subroutines and pass them around. You're actually compiling code with this thing. What you're writing is a compiler in Perl that can insert new code for the Perl compiler when it compiles your Perl program.
So it's a preprocessor.
Of a sort. So what this says is I'm going to create a thing called treefold. And a treefold takes a pair of items off the stack, does something to them, another pair. When it's consumed the whole stack, it calls itself again. And it keeps cycling through. Now notice that QQ, this is source code. I am not generating a code reference. I'm not putting together some pieces of code. I'm actually putting together text. So I'm going to take I'm going to create a thing here. It's called treefold. If you declare a treefold, you give me a name and you give me a block. And I'm going to say, look, I'm going to create a new subroutine with your name that sets add underscore to whatever you want it done, whatever you want to create the new list for, and I'm going to go back. The thing then is, this is what the code now looks like. So I have treefold, I'll call it reduce hash. So you compute a bunch of SHA 256s, you compute the count, you give it a map, and I will take care of calling your code until the stack is down to one item. The go-to went away, the assignment to add underscore went away. Put these as macros in parts of your program, and it makes it a lot easier to write really simple code. The other advantage to it is because the Perl compiler actually processes your code. It's not just a whole bunch of subroutines calling subroutines. It's quite efficient. Now, this isn't quite functional Perl, because remember I said data was constant. In functional programming, you want not to modify things. You want to produce new copies of things. The big bugaboo with functional programming is it assumes that copying data is free. It isn't always. In this case, it pretty much is, because I'm just reassigning it onto the stack. So what I can do is this. Instead of splicing off the stack, what I'm going to do here, I'm going to compute the last value, and notice this is an offset now, because I subtract 1 from it. So from 0 to my last offset, I'm going to compute, I'm going to skip by 2s. And I'm going to say, look, if there's a number on the stack at the offset +1, compute an SHA of 2 of them. Otherwise, just take the value that's there. This doesn't modify anything. It produces a new copy of the stack. Does that make sense? Everyone, you're going to heartbeat.
A new copy of the stack that has different values than the last
Copy of the stack that has half as many values, because I'm going to take an SHA of a pair, or if there's only one item left, I'll take that last item.
So it has modified things.
Copy. It produces a new copy of the data. It doesn't change what's in the existing stack. The other one did a splice. It actually took items off the stack. This one produces a completely new copy without changing anything.
Oh. But without changing anything on the old one.
On the old stack, it produces a new copy and says, I'm going to run myself with that new copy, which discards the old one, but then the new one doesn't get modified in place.
Right. It's not putting it back on the stack. It's keeping, as you're saying,
I'm not chewing
now
the stack
charged
off.
for you're taking up more memory, storing it somewhere. Yeah.
Yeah. So this is still a little messy because you got the stacked map here, and you're doing all the add underscore arithmetic up here. This is computing, take the stack over 2 and mods. Most people looking at that. Ugh. So what I'm going to say is this. I'm going to take a new kind of a treefold. And what happens, you're going to give me a list of arguments. And if I do that, I won't go too much into this, but This is how you take a list of arguments and turn them into text. At that point, I can take a subroutine, I can look at your lexical variables. I know how many there are of them, and I can produce code that looks like this, which you can't see the bottom of because we're doing this off the slide here, but trust me, this will chew through your stack using your variable names. I can take, because I know what your variable names are, these list of lexical variables, I can pass them into your code. And the cute thing is, that's what the result is. So that original mess that we saw on the first page with all the plus i's and the nesting and all the rest of it, this does the same thing. You've got a left and a right. If the right value is true, then SHA the left and the right one. Think about the graph before. If there's at least 2 items, SHA the 2 of them. Otherwise, just take the one on the left.
So it's supposed to be 2656, or is it supposed to be 2256?
Ooh, that is called a typo. Sorry about that. Anyway, an SHA 256 of, if there's, you think about it, if there's a right value, then I have 2 things, SHA the pair of them. If there's only one thing, just take the left value. That entire mess that I showed you originally with all the pluses and the rest of it, that is it. That will compute a Glacier hash for you. And if you're looking at a lot of things where you're processing files in a directory, if you're dealing with a lot of network stuff where you've got to chew through something, find out what's there, chew through something, find out what's there, this will actually do it quite efficiently. And this is where I scream the Damian Conway issue. We do well to do better than this. The quick note is, if I look at some sizes for a file, and I use a bunch of different techniques for chewing up the stack with this keyword approach on the end, it actually takes the same or less time to use the 3 lines of code with all the stuff underneath than it did to chew through the stack and do all the shortcuts and the buffering techniques that everyone's ever told me make things faster. The point was that by not messing around with the stack and leaving it in one place and not requiring Perl to have the overhead of manipulating the stack, this code is actually just as fast, if not faster. So, which would you rather maintain? Left, right, SHA the pair of them, or take one, or that entire page of stuff?
But that entire page of stuff is just buried in a library.
No, it's
somewhere,
not.
Right?
No, it's not. Because
Well, or maybe
even
the
then,
middle step is.
but the middle step, the difference is the middle step is that long.
Okay.
The middle step that reassigns the stack and all the rest of it is 12 lines of code.
But it's not, you're not replacing it with just that. You're replacing it with the 12
That
lines.
plus 12 more
that.
lines. But the 12 lines are completely reusable. The next guy that needs to do a tree fold, and there are a dozen mathematical cases for it, they can reuse that same thing. That mess we saw at the beginning does exactly one thing very messily. It will compute a Glacier hash, nothing else. So that was the short version of this. And this is where I pointed out, even Damian Conway can't do better than that. This is starting to look like what it would be in Perl 6 if people want to stay awake for it. I can do that, or I can quit now. The interesting thing about the Perl 6 version, you'll see there's 2 versions of this subroutine. So what this says is, if you have exactly one thing left on the stack, return it. Otherwise, if you've got multiple nodes, redigest all of the nodes. And redigest says take these and recompute it.
I'm more curious about how the chunk size equals 1024 squared.
Oh yeah, in Perl 6
Perl
6 is pure Unicode. If you want to square something, there is a mathematical squared or third or fourth or 10th. If you use the Unicode squared function, you will get a square.
can you still do like caret 2?
Yes, if you like. It works. This is Perl. There's always more than one way to do it. But yes, if you wanted to square something, you can do that easily. Oh, there are quite a few things in here that are fun. There's now same width. Where I had that go to, that's if you call same width, that recycles the stack in Perl 6 so that we don't have go-tos making people run screaming out of the room.
And this is an advantage why?
Because it doesn't use the word go to.
It doesn't use the word go to, it uses the call same width, which is a bit more descriptive and doesn't make it look
Be simpler just to beat people senseless who are afraid of the go-to.
Well, we
no,
used to
because there are
beat
too many of them.
We used to beat people senseless if they used a go to.
Yeah,
So you got to recondition them.
Damn political
Yeah, there are-
programmers.
But this shows, he goes through a few things, and yeah, the version in Perl 6 looks like this. We have a chunk size, which is this. You can change it. One interesting thing is that you have typed variables. We have a treefold, which takes an A and a B, and I basically combine them this way. By pushing a few things into a module, he gets it down to this much code. That was it.
Why would I have ever needed Haskell or Scala? I missed that part.
Well,
No, you didn't.
there are a lot of people who really like Haskell and Scala. If you're into functional programming, part of it is a religious issue. It's like Python Nazis. They like functional because it's functional. And there are some things functional programming does exceptionally well. And there's some things it absolutely stinks at. The wonderful thing about Perl 6 is that you can mix things. You can use the functional where it works and switch to imperative where it doesn't. So if you want to read a line of text from the keyboard, you can just say, read a line of text from the keyboard. You can't do that in Scala because you have to read from a place and it had to return exactly the same value every time you called it with the same arguments. The point is, if I'm debugging my code, and if every time I call a function, every function returns its output defined completely by its input, and for any given input must return exactly the same value of output. If I can validate that this function does for the input what it does, I'm done.
It's how you
The
can test
input
function.
allows me to say, this function takes these inputs and must return that output for these inputs. Not, if I give it these inputs and the history of the object is such that it does this, 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 and if that object there hasn't changed this, then you might get the same output. Well, testing in functional programming just gets a hell of a lot easier. On the other hand, it gets a little unrealistic if one of the things you want to test is a random number generator. Or a pseudo-random generator, or a read from a network cable. If I got the same chunk of data every time I read from the network, I might not get very much done.
But if you you're conflating the two a little bit because it returns the same output for any given input.
And
So
if
if
the
you
input
run-
is a file handle,
If you run read line against a file or against the keyboard and you always take the same input, read line should always return the same output.
but the problem is that with the actual definition, read line can't be called without an argument. You have a read line and a file handle. And for that file handle, read line must always return identical input, period. So if I give it standard in as the file handle, FP definition is that you must return identical output for standard in every time you call it. If I call a time function, time must take an argument, and the argument to time, the return value of time, must be defined entirely by that argument, which is not a reasonable thing to do. So they have monads, and there are all sorts of technical, theoretical things that Haskell is a very simple fix for it. There's a hidden variable you don't have to pass in explicitly that contains the entire state of the universe, and therefore it's completely defined by its inputs. Now, how they fit the entire state of the universe into one integer, I don't know.
42.
That's part of the magic of Haskell.
It's 42.
Bingo!
Very big integer.
But, yeah, for the beauty of Perl 6 is that the functional part is built in. You can do perfectly declarative code if you want to. You can do imperative code if you want to. There are times when each of them breaks down because it just doesn't handle stuff as well. And because you can mix them easily, and it's got the utilities for functional programming with runtime type matching in the arguments. So I can say if I call this with a long list, go here. If I call this with one item, go there. So it's 2 lines to do the tree hash, because you have one thing that says if I have one item on the stack, return it. Otherwise, recurse that's something you don't get in any other imperative languages. That the typing that allows you to have multiple signatures for the function, and say dispatch based on what you see. And that's determined at runtime, not at compile time, which solves a big problem with C++. So, for example, in C++, if I something, first argument where a last argument can do it if it's more derived. Conversation for a later time, but if people are interested in how this kind of programming works, the great thing about it when it works is the code is much more declarative. If you look at the code that I had there, if left and right do this, otherwise do that. But yeah, if there's 2 of them, do this with it. If not, do that with it. I've said what it looks like. You don't have to spend as much time describing the guts of it and what will happen inside. Most of the code in imperative land is if logic. If I'm iterating through, and if this thing is that, you spend most of your time writing if cases. Go do this, and having the function header, the function prototype, declare if I'm getting these things, I want to be here. If I'm getting these things, get there. Again, and when people are awake, if I can come back and describe why some of this is useful. But at this point, probably all of us just need either food or a drink.
Or both.
Yeah, or both.
Well, let's jump back one partial thing.
Yeah.
So getting back to the usefulness of this.
Yeah.
So the SHA or Glacier is acting as an index.
No, the SHA is if I've uploaded a petabyte of data, I don't want to have to re-upload all of it if one chunk is no good.
Okay.
How many people here remember modems? Remember Kermit? Remember blowing up at the end of a 3-hour download? Oh my God, I finally got, oh no! And there's no way to restart it. Okay, when all you were loading was a couple of mega GCC, I got a good beer story about that one. This. Now let's say one of the data sets that I work with on a regular basis is the nr.gz file, which is, I think, 10 gigabytes daily download. It's got 92 million records in it. You do not want to get to 9.875 gig and have to start over. So the idea there is you chunk it. I want to upload the thing in parallel. I can get multiple servers. And if I've got multiple upload channels to Amazon, I can use 45 cell phones and just have one stream on each of them and get pretty decent service. The trick there is, how do I verify all of it when I'm done? Now, if you give me one checksum for all of it and one checksum for each piece, you can still have problems because of digest collisions. When you're dealing with a terabyte, multiple terabytes of data, SHA-256s aren't good enough. And I've got a great example of that if you want me to give a talk on the nr.gz file. But the problem is digests have collisions. So you want to find a way of making it so that you can tell which piece of something failed if it comes up bad, and know that the whole thing did or didn't work. So that's where you start with the 1 meg chunks, and you take 1 megabyte in SHA, all of those. If you're uploading 1 file, you do the tree once, you send 1 digest, and it's there. They compute it the same way. And because you've digested the digests, the odds of getting the same thing at the end are so minuscule advantage. But let's say I'm uploading a terabyte. I can break it into 2 meg, 4 meg, 128 meg, 256 meg pieces. What happens? It's the same logic as I take the megs and I take that tree and I get a point. Then I ship 128 meg with the digest of that 128 meg. If that blows up, if that does not match, Amazon tells me you blew it in this chunk. Or this chunk, or this chunk, or this chunk. I can upload them in parallel, and it can continue the process when it gets all the chunks, and it will be the same. Now, if I send 4 meg chunks, 8 meg chunks, 128 meg chunks, what am I going to do? 1 meg, pairs, 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 pairs. I send all these, and they keep going with the pairs when they get them.
How do you sequence the chunk?
When you're sending them to Amazon, when you upload a chunk, you put a counter on it. And when it gets them, it resequences them all. And one advantage to that is if you get an error, you can resend a chunk as part of an upload ID. And until it gets all of the chunks correct, you can, if you send up a petabyte and you blow 42 of them, you can get a bad upload on one of the early ones and resend it and have it be fine by the time the last one goes through.
Have you ever actually gotten a bad upload?
Oh, yes. Oh, yes. Oh, yes. Oh, yes, yes, yes. If you're not on fiber and you're on a nice windy night and you've got charter and those power lines are slapping around enough and you blow the main heavy duty fuse in the alley on the 105 kV unit, you can get all kinds of bad data coming down the wire. Another thing that happens, and it does happen, is you get run chunks. When you're starting to move, when you think about packet counts, if I'm uploading 8 megabit chunks in 1500 bit packets, and I'm uploading a few petabytes, have you ever maybe just kind of lost a packet or got a run packet off the wire? Yeah. So that's enough. If you're moving that much data, you can start to see it. You don't notice it when you're just hitting a website. You know, if you're streaming porn, if 1 pixel goes bad, nobody cares.
Oh.
Yeah, so
Should we draw any conclusions? Because that's his example.
what is most of the network traffic today? There are 2 things that make up most of the traffic on the net worldwide today. What are they?
Hillary's email.
Netflix.
Spam and porn.
Netflix.
Actually, porn still outruns Netflix worldwide. There are lots of places you can't get to Netflix, but what was the only profitable business on the internet, the name of the company that had the first profitable internet business? Persian Kitty. What was the single most heavily trafficked news group for its entire lifetime?
Alt.binary.pictures.
Alt.sex.erotica.bin. Okay? Where was the, think back to the original internet. It was straight text. Then we got pictures, we got JPEGs. Who brought us JPEGs?
The porn industry.
Bingo. They hacked it in. Then we had video. What were the first sites you could get video on? Porn. Porn and spam. And spam takes up so much more internet traffic in total than Netflix is capable of even issuing that it's not funny. So basically, junk is the majority of it, sir.
Actually, I think it was back around 2000 where I read an article that they said the MP3 traffic had exceeded the porn traffic on the internet. And then like a week later, they shut down Napster.
Shut down who?
Napster.
Okay, yeah. But having shut down Napster, excuse me, I was about to trip on this. Having shut down Napster, the MP3. The other thing is the MP3 traffic today tends to go much more over wireless. It goes over the phones, where the cables tend now to be more Netflix, porn, and BAM. Especially if you go on business traffic. The number of companies that have yet to figure out how to keep people from watching porn at work.
Getting back up to the immediate question.
Yeah.
So these failures though are not being caught by TCP.
Right. If you're moving a petabyte over TCP, there are plenty of ways that software that picked it up off the disk could have botched it. You could get a bad disk read, you could get a bad network read, you could get a
If you get a bad disk read, you're still going to compute a bad hash. The hash will be okay.
that depends. Depends on when you compute the hash or when you read the thing. There are lots and lots of ways. I mean, one of the things you can do with these is you pre-read them, you pre-compute the hashes, and then you actually chunk the files and write them as you're going. You can have problems where you get a disk read where you compute the hash and the value goes into swap. It's written to swap and then gets read back from swap into core to be transmitted over the wire. Because if I'm moving a petabyte of data, I'm very likely to exceed the physical RAM on my machine. So you're assuming that the only time something touches the disk is when I actually perform the initial read on it.
No,
I can
I'm
say
saying
that
that's
in
not a
virtual
problem with
memory.
TCP.
Well,
If you read the disk off the disk twice and get two different things, you've got a different problem than Glacier or TCP.
right. I'm just pointing out that if I read the stuff up into memory, I compute the hashes, and while I'm transmitting it, that block gets written to the disk. There's a risk that that thing may get pulled back up and transmitted in a different way than when I computed the hash.
Yes.
Okay, at that point, having the hash on the other end allows them to validate that what they received is what I sent.
If you've got that problem, you've got bigger problems than sending bad data to Glacier.
Well, no, again, if you're starting to deal in petabytes, the cumulative rate of error, even with very, very, very low odds of one packet getting blown, or one run packet, or one run disk read, or, I mean, how many layers of software can you get between you and the physical medium, one of which might drop part of the page? No.
Gary knows where I went with that.
No. Layers of network model, yes, but layers of code, how many libraries call libraries that pass your chunk of data through them in the time it takes to get that thing from ones and zeros on a spinning platter or SSD, up over a cable, up through the kernel, up, I mean, there's a 1-bit screw up in any of them managing the memory footprint of what you're moving can give you an error at the other end. And again, if you're moving this stuff, if you move enough data, you know, anyone here use error correcting modems? Anyone go back that far?
We all would have.
Okay. Has anyone here ever gotten an error transmitting data on an error correcting modem? Case in point. You're making the bad assumption that the software that corrects the errors has no flaws of its own.
I'm saying you have a bigger problem if that happens. It's a different problem than you're trying to fix with the hash.
But the point is, I don't want to upload a petabyte of data, discard it from my local server, my local storage, and find out 5 years from now it was corrupt when I sent it. That's the
Okay.
point.
Yeah.
At that point, the hashes allow me to take a very, very large footprint of data, break it into smaller pieces that are easier to retransmit all of them, retransmit the ones I need to, if they detect you want to detect the errors at the other end. The tree hash approach, where I'm rehashing the hashes, helps avoid hash collision issues. Because I'm intermingling multiple hashes on the same data. There are so many fewer ways to come up with a hash that collides that it helps. You just add it in. And, Glacier's an interesting service, but as SysAdmin is, one of the interesting things about it is you can put enormous amounts onto it. You can upload it in parallel. But Amazon doesn't have a nice little quick GUI where you drag and drop a file. You've got to use software on your end to manage just about all of it. To get an inventory takes 5 hours. The module I'm nearly done with finally that manages this stuff takes a month and a half to test. Because it's 5 hours from the time I issue an inventory request to the time I actually get it. So if I'm running a series of tests to upload a file, a 40-byte file, I mean, the Perl test uploads a copy of itself. It's uploaded, 80, less than a kilobyte, 85 bytes in some case. It just uploads a little tiny piece of data and says, do I see that in the inventory? And then I delete it and say, is it gone from the inventory? And then I say I try and retrieve it, and do I correctly get an error that says it's not in the inventory? That's 22 hours. Wow. Well, but now let's say I run, if I run 200 or 300 tests, I type prove, and I just background and come back next week. It might take 15 minutes if they're a busy day. Because what they have to do to get that inventory is they have to go onto their own archives. If you want to get some of the stuff, they have to they try not to reread the tape. But
So it might be in a cache.
So yeah, the way you do it is you request an inventory that gives you a job ID. And then you can query them to see is the job complete. And then when the job says complete, you can go download the data. To download an inventory is instantaneous. If you want to acquire data, you say, I want to download this file. You can go get the file.
So the inventory is by file?
The inventory is done by file. Actually, it's done by ID. You upload everything. You have no file naming. You assign an identifier at your end, and they give you an identifier of what they call it. It's all numeric. It's a surrogate key. You request it again by their surrogate key. When you get the inventory, it takes your tag, and what you get is a file size, an upload date, your tag, and their surrogate key. If you do not tag things effectively, you're toast. Because you don't drop it, they don't upload it with a file name. When they receive the bytes, they assign a surrogate key to it and say, hi, this is your upload number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you don't know what that one is, they don't care, they don't know.
So it's file based.
It's all file based. You upload a file into a what you create are vaults. And a vault is a storage unit. It has an ID, and it's just a storage collection of files. And then you get the IDs back later. Like I said, the interesting is you can have a job, you request a job to do a retrieval of a file, you request a job to get an inventory of the files you have.
So basically you can't run RSA against.
No. Unless your rsync has a very, very, very long. But again, if I'm doing a test of upload a trivial file, verify that it was uploaded, download it, verify it came back right, delete it, verify it was deleted, attempt to download it, detect that it correctly wasn't there when I tried to download it.
You have to run that test.
about every time you modify the code, you make sure you didn't fuck the code up that does it.
Well, yeah, but I'm saying that's acceptance test. You know,
It's simple regression testing, yeah.
Yeah.
I just generally run, well, you think of the places, there are people who have systems where every time they save a file, they run tests. Which means you can, using something like this, you wouldn't be able to save more than once a week. It's just, every time I run these tests to verify what I'm doing. Now, obviously, one of the things I do, and it's actually easy to do in Perl, if people are interested, I can show you how to do it, is you can stub pieces of things. In Perl, stubbing something that's out there is very easy to do. So for most things, I have a stored copy of the thing, and I overwrite the thing that requests the inventory to immediately return a canned copy of an inventory that I can process. But if I want to check if I'm dealing with reality, I've got to run the real tests. And running the real tests can take, for a few of these things, 15 to 25 hours. It's basically, like I said, what they've got is multiple tape libraries that are each the size of multiple football fields. And just lots and lots of little robotic arms and a big mother of a duplicated database that tells me which tape blocks are which pieces of which uploads.
And they have this Glacier duplicated at multiple locations.
For
redundancy.
How they back it up, how they put it on tape, but if you look at the retrieval times, it's 5 hours, which is about the kind of time it takes to assemble a bunch of tapes, put them into a bunch of readers, stream it off the disk, reassemble the pieces in one, and say, "Hi, we're ready for your upload." So it's a marvelous service if you've got cold data that you want to keep indefinitely. If you were the Motion Picture Society and you wanted to store digital archives, digitized movies, really high quality digitized movies and stuff that you don't want to handle the reels often enough to go through the process of digitizing, and you don't want to expose them to the light, which fades them. So you want to take these things and create these digital archives, and you don't want to have to recreate them. This is a great backup medium for something like that. You'll probably never ever touch it. If you do, fine, you can get it. But it's not something for storing your trip photos on, because it takes 5 hours to access.
Awesome. Steve Lombard, thank you very much. I think Steve's going to come to Denny's. You can come to Denny's.
Mm-hmm.
Anyone wants to
I gotta eat something.
Over a little bit of food. Come to Denny's. Anyone need directions? Talk to Lee. Thank you all for coming.
I'm just going to follow somebody.
That'll work too.